Okay, welcome to CULINOLOGY 101. Okay, week 7. Week 7, we can talk about the process of science. Okay. So let's start with the guiding principles of scientific inquiry. Okay. So now currently you are in the program CULINOLOGY. Okay. So as you know, CULINOLOGY is a hybrid program. Okay, so it's not chef, it's not scientist, it's half. Okay, so it's if half of the chef, half of the food science and technologies. Okay, so it's a half. So what happened, right, is that you will require science. Okay, that's why this is a science degree. Okay, because you involve science. Okay, because you do experiments. Okay, experiments, there's a set of hypotheses and so forth. Okay, so this part is more or less just to clarify that part, because when it comes to science, okay, you will need to have a certain process in order for you to test a certain hypothesis. Okay, so if not, your scientific experiment, right, is going to go everywhere. Okay, so there's a set guideline what you should do first, second, third, and fourth. Okay, so let's go to the questions. What is science? Science is a way of learning about the natural world. Okay, science also includes all the knowledge gained from exploring the natural world through observation and experiment. Okay, this is very true for culinologists. Okay, you guys culinologists, because what happened is that you guys is learning about the food. Okay, learning about food, how is food being processed into a certain product. Okay, how the product react in certain conditions. Okay, including storing, okay, cooling, heating, and so forth. Okay, so all this is through this is what we call the science. Okay, so what you guys are doing is going through the observation and experiment. Like for example, when you observe something, you say that my product is a bit hard. Right after like half an hour to 1 hour, my product is getting more and more hard. So you go back and look at what could it be. It could be because your food is made of starch. So as you store longer and longer, what happens is that it will go through a process called retrogradations. Okay, so what you can do, right, is that you have to prove that it's really due to retrogradations. All right, so retrogradation happen the least, okay, in the freezing condition. So what you can do is you freeze it and see whether it gets soft or not. Get harder or not. Okay, so you can do experiment to test it out. Okay, or another way is that you can actually add technical ingredient to actually stop the retrogradation. Okay, you can do that. Okay, experiments. Okay, so the scientific methods process, it all start with asking a question. You can either ask a question or you have identified a problem. Okay, most of the time is you will identify a problem. Okay, then what happens, right, is that you will construct a hypothesis. Okay, a hypothesis is basically a set of theory that to explain a certain thing. Alright, so once you have a hypothesis, then you will perform an experiment to prove your hypothesis whether it's true or false. Okay, then of course after experiment you need to analyze the data and create a conclusion. If it's not supported, then you will create a new hypothesis. Okay, then redo the whole thing again. Okay, whereas if conclude supported, then you will need to perform additional experiment to confirm that this is what you get. That's why, because of this hypothesis, okay, experiment, analysis data, and conclusion, it takes time. Okay, especially if you're looking at the for culinologists, okay, it's more towards the recipe. Okay, recipe contains a lot of ingredients. Okay, so possible it could come from any of the ingredients. Okay, so what happens is that you need to test one by one. Okay, so you say that it could be this ingredient, then you test it is not this ingredient, then it could be that ingredient and so forth. In that case, same as technical ingredient, you will say that maybe I can add this ingredient, okay, technical ingredient, to stop the retrogradation. Okay, so what happens when you test the experiment and say, not really, it's not really stopping it. So you create a new hypothesis, say that, another technical ingredient can do it. So you do the same experiment again, and to analyze the data to see whether it will stop the retrogradation from happening. Okay, so I give you a very simple examples here. Okay, so for example, in the class, okay, student A, student B, student C, student D fell asleep during my class. So I will say, why? Why is it that they are falling asleep? So what happened is that I will construct a hypothesis. Okay, so this is the definition. Hypothesis is a proposed explanation made on the basis of limited evidence as a starting point for further investigation. Usually, all these, if you got experience, the limited evidence could come from your experience as well. Okay, that you can use it to form a hypothesis or construct a hypothesis. So based on my hypothesis, okay, I can construct a hypothesis and say that maybe because they did not have breakfast, okay, so that's why they fall asleep in my class, because that could be a problem because you got no energy. So what happened is that student A and student B were given breakfast, called the breakfast group, BG, breakfast group. Students C and D, they were not given breakfast. They call it as non-breakfast group, okay, or what we call control group, before coming to my class. So I will perform the experiment and then see whether they fell asleep or not. And what happened is that my hypothesis is true. Breakfast group, okay, which is student A and student B, they are not feeling asleep. Okay, they are not feeling sleepy. For non-breakfast group C and D, they fell asleep during my class. So what happened is that my conclusion is that breakfast is required, okay, to make the students not sleepy. So it seems that it supported my hypothesis. So what I should do next is that I should repeat the experiment. Okay, I should repeat for all of them, or maybe I can repeat for C and D, student C and D, which I haven't tested yet. Okay, so I can test C and D, A and B, non-breakfast group, and then to see whether I come up with the same conclusion. If you come out with the conclusion, then it's so more or less it fixed that breakfast is required before the class so that they don't feel sleepy. Okay, so this is a very, very simple explanation of how you can do it. Okay, from a question, a problem, okay, construct a hypothesis, perform an experiment, and analyze that, create a conclusions. Okay, that is why when you do R&D, especially in your third year, it will take time. If you take time, it's not like say 1 week I finish everything. It cannot be. Okay, more or less you will take whole semester or maybe 1 year to actually conclude it. Okay, that's the reason, because your recipe is just not one. A recipe inside a lot of different ingredients and a lot of processes. Alright, so this is terminology. What we have is what we call independent variable, IV, or dependent variable, DV. Okay, independent variable is a manipulated variable. Okay, is the variable you are going to change in the experiment. Okay, the explanation, okay, or example I given to you is food or without food. Okay, So is food without food is called independent variable. Okay, food is the independent variable. Dependent variable, which is responding to outcome of the variable, okay, or is a variable you observe when the independent variable is changed, is the sleepiness. Okay, so all your experiment, you should be able to identify what is the independent variable and which one is the dependent variable. And it's very crucial that when you do an experiment, make sure that you change one thing at a time, not several things at a time. Okay, if you change several things in the time, you do know what is the responsible thing. Okay, for example, if you say that you are testing a certain technical ingredient, okay, for example, to test that you want to slow down the retrogradation with the technical ingredient. So what you do that is that, alright, I say that, okay, this is more or less the seller is telling me this technical ingredient that is able to slow down the retrogradation. So what happened is that, by the way, retrogradation is the aligning of the starch, okay, after it's removed from the heat, and it will lead to hardening of the carbohydrate rich food. Okay, so what happened, right, is that you can test. The first thing is that you test different concentration of the technical ingredient. You can test 0.5, 1%, 1.5%, 2% of this technical ingredient only. Okay, so test one thing at a time. You cannot test like, oh, I add this and add this technical ingredient. You don't know which one is doing it. So you can do just this technical ingredient, different concentration, and you see which one can slow down the retrogradation. Okay. Okay, so this one is the summary of the scientific methods here, of what I have mentioned just now.
What makes the wind blow? How do birds fly? Our world is full of curious phenomena. To find answers or solve problems, we can use a process which was first acknowledged by the scientist and philosopher Ibn al-Haytham in the 11th century. Also known as Alhazen, he is considered to be the father of optics and the scientific method. There are 6 steps to it. 1. Observe and ask questions. 2. Research. 3. Formulate a hypothesis. 4. Test your hypothesis. 5. Conclude. 6. Share results. The goal of the scientific method is to find out the truth. Let's try. Step 1. Observe and question. Observation helps us formulate challenging questions that you will be able to test. A good question converts the natural sense of wonder into a focused line of investigation. When is the best time to drive to school? Which food is my dog's favorite? For example, if you observe that women smile more often than men, you might ask, why do women smile more often? Step 2. Research. Find out if other people have asked the same or similar questions. If you research online, use search terms like study, research, or meta-analysis, which is a summary of research for a specific topic. Read as much as you can about your particular subject to see what you can find out about. For example, research happiness based on gender, or study the science of smiling in different cultural contexts. Step 3. Formulate a hypothesis. A hypothesis is a theory that you can test to see if your prediction is right or wrong. From your observation, you have noticed that women smile more often and that people who are smiling seem to be happy. From your research, you know that there are different types of smiles: shy, genuine, and false. In one paper, you read that baby girls smile more often than baby boys. Here is a hypothesis. Women smile more than men because they are happier than men. Step 4. Test your hypothesis. When you test your hypothesis, you want to make sure to do this in a fair way and that the conditions are constant. For this hypothesis, we can design a test where an interviewer talks with a set of men and women for 5 minutes each, counts how many times they smile, and then asks each one to rate their level of happiness. To get a good sample of the population, we invite 300 women and 300 men. Seems like a good test, right? But wait, what if the interviewer is a woman and men tend to smile more at women? Or vice versa? Or what if the topic discussed is one that interests women more than men? And what if people aren't reliable reporters of their actual level of happiness? So clearly, we would need to be much more careful. Step 5. Analyze and conclude. Let's assume that you designed a very careful experiment, controlling for as many variables as possible. Now you can analyze the data to see if your hypothesis is correct or incorrect. Depending on your findings, you may want to change your hypothesis or change the design of your testing. Perhaps you have discovered an even more interesting question. This stage of the scientific method can be repeated as many times as necessary until you find just the right hypothesis and test method to find accurate results. Step 6. Share the results. When you are satisfied that you have proven or disproven something important, report your results. In science, it is important to detail your methods so that your peers can review your work, which is a critical step to getting published. If your results are solid, your experiment can be repeated by other scientists. Such reproducibility is a sign of good scientific work. But failed results can also be interesting. An incorrect prediction could prove to be important and should always be reported. To make sure you get it completely right, here are 3 more things you can check before you publish. A. Any scientific theory is falsifiable. Real scientists know that there is no such thing as a scientific proof. In other words, you can never prove your theory to be 100% right. All you can do is find a lot of supporting evidence that it could be correct. Here is one example. Say that someone says, hamsters can fly. We cannot prove that this is false. Yes, we have never seen a hamster fly, but we can't test all possible conditions or look in all possible places on the planet to know that all hamsters never fly. Maybe a space hamster does. So while we can often prove that a phenomenon exists, it's much harder to prove the non-existence of something. If your theory can't possibly be proven wrong, then it's not falsifiable and hence not scientific. B. Correlation is not causation. When you analyze your results, it is important to separate between 2 possible reasons: correlation or causation. Let's say you hear that towns that have more churches also have more bars. Could it be that religion makes people want to drink, or that drinking helps people to find God? If you add more facts, such as larger towns have both more bars and more churches, you can see that a larger population is a more likely cause of higher numbers of bars and churches. There is probably a correlation, but no causation. If we compare men with women and would conclude that women smile more and are more happy, then this still doesn't mean that it's happiness that makes them smile. Maybe they just eat more chocolate and cookies, which makes them both happy and smile a lot. C. Avoid selective windowing. When you publish, you've got to show all relevant facts. Colgate once ran an advertising campaign claiming that 80% of dentists recommend Colgate. What they didn't tell us is that when they asked dentists to select their preferred toothpaste, Colgate was just one of many other brands they also recommended. Colgate was later sued and forced to take down their misleading ads. The purpose of science is always to find out the truth and nothing but the truth. To use science to mislead us is wrong and terrible business practice. Let's do a last example together.
Okay, so you can see from there, Okay, once you've done that already, right, then you will need to share the result for your case as a culinologist. Okay, of course it will be P&C. Okay, you cannot share it to other people because your research is going to develop food products. Okay, develop food products that use it for of course to make money for your company. Okay, so that cannot be shared, but of course certain if it is technological purposes, you actually can share. Okay, you can publish it, so you become the expert in certain technology. Okay, okay, so some things can share, some things cannot share, obviously. Once you have get the result already, right, for those that can share, okay, there is a gap. Okay, it comes to the second section that I want to talk about. There is actually a gap between research, okay, the result you get, okay, to the public. Okay, so there's a gap between that. So so it comes to the second one. That's got to do with the science, technology, and the society. Alright, so the scientists, culinologists do a certain experiment. Okay, they get the results, they publish, but usually the results is not accessible by the public. Okay, so there's a gap between that. Alright, if you haven't been know by now, okay, so you can actually watch this video. Okay, this type video is talking about the dangerous gap between science and the public. What happened, right, is that there is a opinion gap between the public and the scientists. It's not connecting. The public and the scientists, right, is not really connecting. Okay, one of the reason, right, is that a lot of the scientific publications is not open access to the public. Okay, by now, if you didn't realize, right, a lot of the research, what happened is that the publications, you actually need to buy it. Okay, you need to buy it in order to view it. That's why in the library, okay, you can access a lot of the journal is because the library, Taylor's University Library, subscribe to the journal. That's why you can access to the articles. Okay, if there's no subscription to the journals, you cannot access the research data. Okay, so what happened is that public usually have a certain limitation access to the publications. So because of this, they created a gap. Okay, in this video, right, later you can watch it as well. Okay, that is why nowadays there are a lot of different scientists that actually want to bridge between the science, technology with the public. That's why they created a lot of the website, blog, Twitter, and so forth to actually inform or connect with the public. Okay, so you can go to this website as well, usefulscience.org. Okay, /nutrition. Very interesting. Basically, they just take one sentence to summarize the journal article. Okay, so when the public, okay, which is not scientific, when they see, they understand. Consuming 2 or more glasses of sugar, sweetened or artificial sweetened soft drink per day is associated with all-cause mortality. Okay, so very clear. Okay, just one sentence, and this is based on this article. Okay, so a public can understand this very easy. Okay, so another one is scienceworthy.com. Okay, more lengthy than this one. Okay, 7-minute read. Using essential oil to preserve delicate fish fillet. Okay, so basically they summarize, okay, what is in the research article, okay, into a public able to understand. Okay, another example is this. This is the paid publication. Okay, I have included in your WEEK7 handout 2. Okay, so you can read this as well. This is the paid publications. Okay, which means that you need to pay to access to this article. Shear stress mediated refolding of protein from aggregates and inclusion bodies. This article is talking about a technology that is able to unfold a protein. Okay, by doing that, you actually can reuse, or you can use the protein for to design for another purpose. Okay, so if a public read this, public cannot access to this, and then another thing is public, when they read this, probably they don't understand. So what happened is that got one of the infographic, or one of the scientists actually created this infographic, okay, to explain the whole thing. Okay, you can go to this, it's called blog.drawscience.org. Basically, they have converted all the information into the infographic in order for the public to understand. Okay, draw science. So you can see that they write there how to unboil an egg. It's true, because in the experiment they actually use a boiled egg as a example. Okay, so what happened is that they boil egg, they use the urea, unfold it, and then they use this device called the vortex fluid device to actually spread on the columns. Okay, by spreading on the columns, okay, they actually can form a thin film, and they actually can refold into another form. Okay, so to refold to another form, why is it useful? It's because it can also apply to some other type of proteins, like the bacteria, which is a cheap source of which is a very cheap source, okay, that you can use to create protein. Okay, usually bacteria will create the protein that is being coiled. Okay, they folded. So what happened, right? They can use technology to actually unfold the protein created the bacteria and refold into something they want. Okay, so it's very smart. They actually refold into something they want, and they can use it to do something else. Okay, so public, when read this, easy to understand. Okay, and it's freely available for public to access. So it's so you see that there's actually a gap between the science and the public. So as a culinologist, probably you can also bridge the gap between the science community and the public. Okay, for you guys, you got the access to the science knowledge, to science journal. Okay, the information from there you actually can translate into the products. So make sure that you can inform the consumer a proper information. Okay, very important. You do not actually so-called give them a wrong information. Okay, so make sure okay, you provide a good information. You can start with a blog as well. Okay, for food. Okay, that inform the consumer what's the latest technology. Okay, edible film. Okay, edible packaging. Okay, and so forth. Okay, so they understand that there's this kind of technology. Okay, a lot of the restaurant owners, some of the manufacturing as well, a lot of them, they actually do not have access to this kind of information. So this information is very good to actually bridge the public, so public aware of what is happening. Okay, so I will stop here. So make sure that you go to the Padlet. Okay, and if you got question, please ask question. If you got no question, please write there no questions. Okay, as again is for attendance taking. Okay, so for your work is to explore this kind of website. Okay, go to this. Okay, go to this. Useful sign on nutrition and so forth. Go and search some relevant, interesting topic. Okay. So that you know that what is available, okay, for the public. All right. Okay, thank you very much.